All right, so here are some examples, right? And I've put a abbreviated activity series on the side there. Okay, you do not need to memorize the activity series. When we get to our solubility rules in our next, in a couple sections from now, you will need to memorize those, but activity series, you do not need to memorize the activity series. Okay, so when we do these, we need to check our activity series. So here I'm going to have aluminum wire in a copper 2 nitrate solution. So let's turn to another page. So my aluminum wire, okay, so that's a solid. We're going to put it in a copper 2 nitrate solution. And then what I have to do is I have to look at my activity series. Let's find aluminum and copper. There's aluminum and there's copper. So aluminum is more active than copper, which means aluminum wants to be an ion more, right? Which means that this reaction will proceed. Okay? And then I have to balance it. So my balance, I'm going to have 2 there, 3 there, 2 there, and 3 there. If I were to write my net ionic equation, I'd get my aluminum my copper 2, giving me aluminum and my copper. Okay, I can check my charge balance. So this would have an oxidation number of 0. Each copper would have an oxidation number of 2. Each aluminum ion would have an oxidation number of 3. And that would be 0. So, again, plus 0 plus 2, or 3 times plus 2 gives me plus 6. Then I'm going to have 2 times plus 3 plus 0 gives me plus 6, and 6 equals 6. So we're good on that. Okay. All right. Okay, so our next one says that copper wire is placed in a solution of magnesium nitrate. So copper wire, a solution of magnesium nitrate. Okay, so let's go back to our activity series. So here's copper again, and here's magnesium. So magnesium is higher up than copper is, so magnesium is more active than copper. Now magnesium nitrate, it's already an ion, because if I were to split this up, I'd get magnesium and 2 nitrate. So magnesium's already an ion. Magnesium's more active, which means it wants to be an ion more, which means nothing's going to happen here because magnesium's already an ion. So I'm going to write NR. NR stands for no reaction. Okay? All right, so let's try our next one. Our next one says magnesium ribbon is placed in a hydrochloric acid solution. Right? So magnesium ribbon in a hydrochloric acid solution. Okay, so let's take a look between magnesium and hydrogen. Okay, so here's magnesium and here's hydrogen. So magnesium is higher up, so magnesium is more active than hydrogen, which means magnesium wants to be an ion more. And in this situation, hydrogen's the ion, so a reaction will occur. Magnesium chloride and hydrogen gas. Then we need to balance it with a 2 in front of there. Okay? So my net ionic equation here would be solid magnesium plus 2 hydrogen ions, giving me magnesium ion plus hydrogen gas. Okay? All right, let's do one more. This time we're going to take some sodium metal and put it in water. Okay, so we're going to get our sodium metal. sodium is up here, hydrogen's there. And sodium, if you recall from the previous video, is one of the ones that can displace hydrogen from water. Back. Let's have the right pen. So sodium is way more active than hydrogen there. So in this reaction, we will get sodium hydroxide and hydrogen gas. Okay, and then we'll balance it with a 2 there, a 2 there, and a 2 there. Okay, so for our single replacement reactions, we have to look at our activity series in order to figure out if the reaction will proceed or not.